This is our Week 2 video for MA 405 Modern Geometry at Bellevue University. This week, instead of focusing on proofs, we're going to focus on GeoGebra. The first time we're asked to use GeoGebra is in Week 2. So within Week 2, I give a little bit of information in the About Week 2 section, but the very next thing asks you to sign up for a GeoGebra account. That is key to your success. If you just click on the link to go into your GeoGebra course without having an account, your progress will not be saved from week to week. So click on the link to sign up for a free GeoGebra account. The sign up is very quick and easy. You can use your Office 365 account, a Google account, etc. Once you're done, you're going to click here on GeoGebra course, which is at the top of your screen. Again, you are going to sign in, so do not complete here where it says name. You want to sign into this course. Once I'm in the course, we can see that I have chapters 1 through 8 and a final project. And navigation you can do in either the left-hand side, clicking from one to the next, or you can go on the main page, begin at section 1.1, and once you've completed all of the tasks, just click next to go into section 1.2. So very easy navigation. Again, keep in mind that you only want to complete whatever sections are assigned each week. Let's take a look now at a basic tools overview in GeoGebra. So again, I'm in section 1.1. It's asking me to do some constructions, and you can see for every construction I have to do, I'm given a place in which to do it. So let's take a look at some of the tools and do a few of these first questions together. So first, I'm trying to construct 2 free points. So to give you an idea of how this works, this is the move tool, and of course you can select objects as well, but typically here you're just going to do the move tool. And you'll find that you click on that box quite often. The first tool in the next box is the point tool. So again, if I'm just creating 2 points, I can click and click. And in this case, I'm actually asked to construct 2 free points and then construct a segment joining them. So we'll get to the segment in a moment. But again, if I wanted to move one of these, I could move these around. If I forgot to click on the move tool and I was still over here at the point, it would just keep creating more and more points. So utilize that undo button as often as you need to. You can also create a point on an object, and that's helpful. Let's go ahead and create this segment and then we'll get to some of those other tools. But if I wanted to create, typically GeoGebra is pretty smart. So if I'm clicking on the line, it's creating a point on that object. I'm going to go back to the move tool and show you that C is in fact on line AB. That would have worked the same if I would have clicked point on object. I would have to click the object first and then the point, but you can see it did exactly the same thing. It created a point on the object. So using that point on object usually is not necessary. You can just create the point. There's also attach detach point. So if I wanted that C to no longer be on segment AB, I could detach it from the object. I can create intersections, midpoints, which we'll be using, and we won't really use the rest of those very often. Obviously, we will use line and segment quite often. And one tip that you might need moving forward, quite often we're asked to create a point on an object, but we want it to go outside of a specific segment. So sometimes you might have to create a segment and then also create a line so that then when I'm using this move, notice this is a point on segment AB, but if I needed to create a point on line AB that was movable, now see it can move outside of just the segment. And that can happen even if I choose to hide this particular segment, if I can remember exactly how to do that. I can click on show object and therefore get rid of the actual line, but we can see that D is still on the line. That happens to be invisible. I believe there's also another way to hide that object, which I'll show you in a moment. Again, we've got line, segment with a certain length. We have array, and we really don't use the rest of those. For the next section, we have perpendicular line, perpendicular bisector, angle bisector, tangents. All of those you will use in this course. Polygon, regular polygon. Obviously, a regular polygon has all side lengths the same length, all angles the same angle. We have circle with center through point. We're not going to cover too much with circles in this course, but just know that those circle tools are there. We will not do any of the conic sections. We do have angles with a given size. We'll use those. Distance, area, those are all very good things to know. We won't do any reflecting. Sliders are helpful and text is helpful. We'll cover more of the sliders and text when we get, and the checkboxes and so forth, when we get to week 4, when we spend a lot of time, week 3, when we spend a lot of time on advanced GeoGebra. And then we've got, of course, move and zoom, and this is the other place to show or hide an object. So I can click on that to show that object again. Let's go ahead and do a couple of constructions together while we're talking about those basic tools. So again, this one I was asked to construct 2 free points and the segment joining them, construct a movable point on the segment. So I'm actually going to just get rid of this guy. I'm just going to click on it and delete. So I have the 2 movable points and the segment, the 2 points and the segment. So again, yes, I can move A and B, and I can move C, but I cannot move it past A and B. And then I want the midpoint of the segment. So I'm going to click here, here, and then click midpoint. And for midpoint, I'm going to select the 2 points, and it's going to create point D. I want you to notice that point D is a different color. That's on purpose, so you can see that that point will move based on where I move A and B. D is not movable. It only moves in relation to A and B, but C is still a movable point. So that's all I would have to do. Now here, I do not have to save task 1. Notice it says all changes saved, so I don't have to worry about saving as I go on. Then again, I can use the line tool, mark the point of intersection. Sometimes you're given a question like, what happens when you attempt to move each of the 5 points on your diagram? So you would go ahead and create the two intersecting lines and the point of intersection, and then you would talk about all of the points. So how am I going to talk about all of the points? I'm going to use text. So I just clicked on the A = 2, click on text, make a text box, and then I could answer whatever I needed to here. I believe that there is no text wrapping feature, so if I keep going here, it's just going to keep going. Let me move this out of the way. Notice how long that's getting. So instead, I would get to the end of this and click return, and notice that's going to make it so that it all sort of fits on the screen. Again, I would continue moving through this and then click next to go to the next section, or click over here to go to the next section. We're going to save most of the advanced GeoGebra topics for next week, or when we cover chapter 3. But for this week, I do want to make sure you have all of the skills that you need in GeoGebra. So I do want to talk about how to find the area of a figure, because task 10, which is section 1.3, asks us to construct a pair of parallel lines, a movable point, points B and C on the other line, etc. So I'm actually going to go ahead and do task 10 with you. So I'm going to construct a pair of parallel lines. So I'm going to create a line, and then I'm going to click on parallel line, and I'm going to click on the line and then just move one down here. So I have a construct a pair of parallel lines, construct a movable point A on one line. Now be careful, because look, This is not a movable point. This moves the entire line. So notice when I added those points, they added A, B, and C, but I need A, B, and C to be particular points. So I'm going to add a point here. This is going to be my movable line on one, and B and C on the other. So now what I'm going to do is I'm just going to basically rename these. I can click on Move, and then I can click right click, and I can change, I can rename this. So I'm going to call this point F. I'm going to call this point G. This was my point A that I wanted, so I'm going to rename that A now that A is available. I need B and C to be these 2 points down here, so I'm going to rename this guy something else, so that's just call that H. And then I'm going to rename this B and rename this C. And then I can go ahead and use that hide tool, show hide object, and I can just get rid of these other things that I don't really need. So what I'm looking for here is I want A to be a movable point on one line and B and C on the other line. Notice when I move A and B and C, it doesn't change the lines. I want the lines to remain static. I want them to be where they are. Now it says construct triangle ABC and measure its area. So I'm going to click on polygon and click on A, B, C, and back to A. And now I have a polygon. I have triangle ABC, and now I want to measure its area. And so I'm going to click on this box and choose area. And it says select polygon, circle, or conic, and I'm going to click that triangle. So I have the area ABC, and now it's asking me to drag point A, and notice that no matter what I do, the area of ABC remains the same. And then it's asking me to explain this in terms of the usual formula for the area of the triangle. That's where I would then go to add a text box. Click, and then I would answer that question there so that it would be on the screen. And I will leave that for you to do. The other thing I wanted to talk to you about is a little bit more complicated. So again, we're going to do this one together, but keep in mind that this is something you're going to need to know how to do. So don't just replicate what I do, make sure you're understanding the steps. I'm going to construct a triangle. So I'm going to create a polygon, ABC, and I'm going to measure each of the interior angles. So I'm going to click on this button and click on angle. And if you ever get confused, just keep clicking until you find the thing that you need. So angle. And I find that the order in which you click is important. Notice I'm clicking in the clockwise fashion, and that gave me the interior angle. If I would have clicked in the other order, it would have given me that exterior angle, which is not what I want. So just if you do it wrong, click undo and then do it right. So again, I'm going to get my 3 angles. Oops, I did that one already. That's what happens when I try to talk and do stuff at the same time. All right, so I've got my 3, my 3 angles and their measures. And I want the sum of the measures to be visible on the construction. So what I need to do there is first find the sum. So over here, I'm going to just name this sum equals, then I'm going to click on this little keyboard in the corner. So I'm going to click on the keyboard, click on ABC, because obviously you can click on any of these. If I click on ABC in the bottom left, I can choose the Greek letters. And notice that we have alpha, beta, and lambda. So that's what I'm going to choose. Alpha, use my keyboard to use plus. Beta, use my keyboard to choose plus. And then choose the last angle and enter. And notice it tells me that the sum is 180. So that's great, except that it says we want the sum of the measures visible on the construction. So what I want to do is now go to a text box. Then I'm going to choose where I want that text to be. I can always move it later using that move tool. And here you can see that not only do I have these values here, down here I have some advanced features. So if you don't see that, just click on the advanced tab. And sometimes it gets a little smaller than we would like it to be. I'm going to go ahead and get rid of that. And I'm going to just scroll down. And what I want is I want to see what is the angle alpha. And if I scroll back up, I can see that it's added alpha. I'm going to add to that beta. So I'm going to choose beta. Again, I can see that it's added beta. And then I'm going to choose lambda. And I can see that it's shown lambda, and then equals, and then I want it to show the sum. So I'm going to click on sum, and we can see whenever that's got that little gold box around it, that means it's something that's being calculated over here on the algebra side. So here I can see the three angles and that they add up to 180. Now if I click my move, notice all of the angle measures are changing as I move this around, and I still get a sum of 180. Now you might have noticed when I inverted this to the other side that that A, B, and C went in the opposite direction, which we don't like, right? So I'm going to click on A, and I want it 0 to 180 all the time. Repeat that for B, 0 to 180. Repeat that for my other angle, vertex C, angle beta. And now when I move this, we can see that it doesn't matter if I invert it, I'm still getting the correct solution. So in this it said construct the triangle, measure the angles, calculate the sum, observe that the sum remains constant. So I'm not asked to do anything else, so we're done with task 11.